All right, so now we're going back to day one where we took a look at the properties of Pascal's triangle. I think on the second or third page, you did the sum of the entries in row n of Pascal's triangle. We saw was 2 to the power of n, and we then simplified, suggested that this meant that Pascal's triangle could be used with combinations. So we're asked to write the sum of the entries of row n equals 4 using combination notation and evaluate the sum. So if it's row 4, we've got 4 items to choose. We're looking at 4 choose 0, plus 4 choose 1, plus 4 choose 2, plus 4 choose 3, plus 4 choose 4. Four choose 1, that's a 1. That's a 4, 6, 4, 1. So this gives us 16, which is indeed 2 to the power of 4. Write the sum of the entries of row n using combination notation and evaluate the sum. So the n row, the nth row would be n choose 0 plus n choose 1 plus n choose 2 plus all the way up until plus n choose n. So that summarizes as 2 to the power of n. And now finally, we're being asked to write this using sigma notation. So I simply write my sigma. I can see that I have to start at the 0th term. So I'll start with, let's say, starting at r equals 0, and I go up to the nth term. Its n stays on top, and the variable on the bottom changes from 0 to n. So that would be, using sigma notation, how to sum up the combinations in the nth row. So in this case, we're going to evaluate. If you do this with our calculator, we get 512. You could punch in each of those, but we also know that, of course, this is just 2 to the power of 9. That's a far easier way than having to sum all of those individual combinations. And in this particular case, the summation from r equals 0 to 10 choose r, the same sort of thing. I know that that's going to be, I could write all that out. That's going to be 10 choose 0 plus 10 choose 1 plus ... plus 10 choose 10. But the nice thing is, from up above here, I know that that's just going to be 2 to the power of 10. If I put that in my calculator, that gives me 1,024. Looking at the symmetry property of Pascal's triangle, we're asked to find 2 entries, not including 1, in a row of Pascal's triangle that are equal. Write the corresponding entries in combination notation. I'm going to go back to Pascal's triangle. So for example, I could look at here and here. That's my 4th row. So it's n choose 1 and n choose 3, right? 4 choose 1, 4 choose 3. So that's one example. So I could say 4 choose 1 is the same as 4 choose 3. 4 choose 1 is equal to 4 choose 3. That's using the symmetry of the triangle. Looking at other examples, come back, I'll choose 5 and 5, which is the same as 5 choose 1, 5 choose 4. I'll choose 10 and 10, 5 choose 2, 5 choose 3. 3 and 3 is 3 choose 1, 3 choose 2. So just summarizing those. So 3 other pairs, we said 5 choose 1 was the same as 5 choose 4. That 5 choose 2 was the same as 5 choose 3. And that 3 choose 1 was the same as 3 choose 2. So can we come up with a general rule for the symmetry property of Pascal's triangle? Can we summarize what that is? Notice that 1 plus 4 is 5, 2 plus 3 is 5, 1 plus 2 is 3. So if I choose from n items, if I choose R items from N, then the symmetrical property says that from that same N items, N minus R will be equal. So this is going to be a property that we'll be using. And now we're going to apply that using the symmetry property, complete the following. 12 choose 4 is going to be the same as 12 choose 8. 4 plus 8 is 12. 15 choose 7 is the same as 15 choose 8, because 7 plus 8 is 15. All right, on your sheet, I think there's some homework, and we'll be able to do that in class. If you've got questions, make sure you remember them so that we can start the next day's class with questions that you have.